Greg, thanks again for joining us here in marketing and to explain what it is that goes into designing a heatsink for a customer. So how does that process begin?
We usually start with a few basic parameters. We call them boundary conditions. So we start with a few boundary conditions, basics like how much airflow we have, how much space constraint we have around the heatsink, and how much power we're dissipating, as well as the ambient temperature of the air coming into the heatsink. So those are the real basic parts that we need to start out with. And sometimes the customer has that information and they give it to us, and usually we double check too. And then other times the customer has parts of the information, like they know what fan they want to use, and they know what kind of chassis they're putting it in, and then we take that information and we do some rough calculations so we can arrive at those things like airflow and stuff like that.
When you get the data from the customer, how do you determine what the problem is so that way you can move forward?
Yeah, well, we usually start out with an analytical analysis. So we put pen to paper and we start out with the basic principles of heat transfer and thermal resistance and stuff like that. So we can understand if what we're trying to achieve is even feasible. And we can come up with some basic parameters just using that analytical analysis. Like we can calculate what kind of heatsink thermal resistance we need, or we could calculate how much airflow we need, or if we have several components in a row, we can calculate what the rough air temperature rise is going to be along that chain of parts. So there's a lot we can do when we get the basic information from the customer. Just on pen and paper.
What's the next step beyond analytical?
Yeah, well, we can do some lab testing, or a lot of times we also use CFD simulations. And if our customer has a model they can supply us, we can plug that into the CFD simulations, and we can come up with an initial heatsink design, and we put that into the simulations as well. And then we set those up and run them. And then the great thing that having done these analytical analyses beforehand, we know what to expect from the CFD simulations. So that way, if the simulations don't run quite right, we already have an understanding of the problem. We know what to expect because CFD is not 100% reliable. I mean, you can go and plug all this stuff in there, but you really have to understand the problem to know if the CFD is giving you a good result. So oftentimes, that is the next stage of the process. And then from there, we can actually produce low-volume prototypes right here in Norwood in our factory. We have CNC machines and manual milling machines, lathes, all that kind of stuff. And we can produce prototypes and test them out here in our labs.
How much of a benefit is it to be able to create a prototype and to be able to turn one around quickly like that?
Oh, it's great. I mean, if we had to wait for, to get parts from China, it'll take weeks to get. We can turn them around here in a few days, and the great thing about that is, we can test them in our labs, and when it comes to getting results, nothing beats the testing. I mean, you can do analytical analysis, you can do CFD simulations, but when you actually test the part, in a situation that's similar to what the actual thing is going to be, I mean, that's where the real, where the real meat comes down.
So we test the prototypes before sending them out to a customer. We do the testing here, or do you send it to them first?
Yeah, it all depends what the customer requires. Sometimes the customer has a chassis that we can't really simulate in our labs, so we might send the prototype heat sinks to the customer, and the customer will actually put them into their system and test them out. Other times the customer, they might have a concept and they don't actually have a product yet, so we'll mock something up in our labs and we'll test it. And it all just depends what the customer needs, and also how complex the problem is. If it's a simple heatsink, pretty simple airflow, we might not need to test that because we understand that pretty well. But if the more complex, the chassis is and how the airflow bends and stuff like that, the greater the benefits we get out of the lab testing.
Well, I appreciate it, Greg. Thank you for taking us through the process of making a heat sink and solving thermal solutions for our customers.
Oh, sure, Josh. Yeah, we love seeing new thermal challenges and coming up with ways to keeping stuff cool.